Hey everybody, let's talk about particle motion and diffusion today. Okay, the first thing I want to make sure that you are aware of and remembering from our conversation in class is that particles are in constant random motion. So if we take a look at a simulation, so this is a PhET sim, and the website phet.colorado.edu is amazing. But if we take a look at this simulation, which is the gases intro, you can actually watch those particles. In real life, we can't see the particles moving. They're too small. But in this case, we can take a look at the particles moving. So for just a second, I want you to watch one particle. Try to follow it. And as you look at it, hopefully you're noticing a couple of things. So first off, all those particles are constantly moving, but the rate at which they're moving changes. So when we talk about particle speed, we're really talking about an average particle speed as those particles are moving, because sometimes they're going to speed up, sometimes they're going to slow down. It depends on what's happening around them. Okay, a couple other things I want to point out is that one, we have those particles traveling in straight lines until they collide. And those straight lines are really pretty random. We regularly talk about the random motion of atoms or particles. And so these are random motions. They're bouncing around. Collisions are going to cause that change in motion, and the speed changes. It could be faster at sometimes, slower at other times, but we'll talk about the average. So there's one more thing I want to talk about and show you with the motion of particles, and that's what happens as we change the temperature. So if I come over here and I heat this system, I increase the temperature. You'll see the temperature slider went up a lot. If you look at the particles, you should see a pretty obvious difference. The particles are moving way faster than they were before, on average. There's still some fast ones and some slow ones, but taken as a whole, they're moving a lot faster. So one thing that can be said, and is certainly important for us to remember and understand, is that at higher temperatures, particles move faster. And at lower temperatures, the particles move slower. So high temperatures fast, low temperatures slow. Okay, so now that we have our particles and we understand that they move and that they're moving randomly, that they're moving in straight lines, changing when they collide, moving faster at higher temperatures, let's take a look at some examples where that movement matters. So the first of these is diffusion, and you probably learned about diffusion in biology, but diffusion is where particles move from an area of high concentration to an area of low concentration. So here's another PhET sim. This is their diffusion sim. And in this case, we see that on one side we have blue particles and on the other side we have red particles. And right now they're separated. Let's focus on the blue ones. So the blue ones have a high concentration on the left side and a lower concentration on the right side. If I remove that divider, very quickly, because of the random motion of those blue particles spread out from where they were super concentrated on the left into where they were less concentrated on the right. And that's going to happen until everything's equally mixed. What happens if we increase the temperature? So now that the temperature is higher, the particles are moving a bit faster. And so if we remove the divider, you see that diffusion happens much more rapidly. And so diffusion is going to happen at a higher rate at higher temperatures. Okay, well, what happens if there's more particles? So in class, we looked at diffusion in a gas with the smelly substance, and then we also looked at diffusion in a liquid when we had the water, and with the food color with the food color diffusing through the water. So what happens if there's more particles? Let's see. You'll notice the blue particles are trying to diffuse, but it's harder for them to get over. It's harder for them to move because there's so many more particles. And so typically we see that diffusion is slower in a liquid and faster in a gas, because in a gas those particles are more readily able to actually move through the space. There's not quite as many collisions to block their way. So we can take this idea of particles and moving and talk not just about diffusion, but about other things you've learned about in the past and the things that you experience on a regular basis. And so one of those is the difference between a solid, a liquid, and a gas on the particle level of things. So it turns out that one of the most important differences between a solid, a liquid, and a gas is the motion and spacing of their particles. So let's assume we have one particular solid. In this case, we're going to represent them with little blue dots. And all of those atoms are in the solid. And you know that solids have a rigid shape. However, those particles are still moving. They're just not moving a lot. They're vibrating back and forth, but they're bumping into one another and they're trapped in place. So there's your solid. In a liquid doesn't have the nicely defined shape. Those particles have a little more motion going on. If you watch, you can see that these particles are moving more. They're actually traveling. And there's a couple that every once in a while kind of escape up. Those would be particles that we're trying to evaporate. They're trying to escape. So our liquid is actually the bulk of the particles down here at the bottom, the ones that are able to move past one another. They are moving more than a solid, but they're still confined. There's a lot of collisions there. So that's your liquid. In a gas, you see those particles are moving even more. And so they're going to spread throughout the container, and there's a lot more motion of each individual particle. And it's the difference in the motion and spacing of the particles that actually gives rise to the behavior of solids, liquids, and gases. So we know that a gas is going to fill its space just because those particles are moving so much more. They're not being attracted to the other particles. They're able to move and take up as much space, and until they collide with something, they're going to keep traveling. Liquids, those particles are they're more stuck together. They're still moving, but the collisions are going to limit that motion some. And then in a solid, again, we've really locked those into place. However, it's really important for me to emphasize right now that at all times, the particles are still moving. So even in a solid, those particles do still move, just less. Okay, so let's take a look at what happens when we start changing the temperature. Let's look at a liquid specifically. In this case, you can see I've got now, this is supposed to be oxygen, little oxygen molecules that are vibrating back and forth. In a liquid, they are moving past one another some. They don't have a really specific rigid shape, so that's why we know it's a liquid. If we start heating these up, notice what happens. Those particles start to move apart a little more. The bulk of it's probably still a liquid, although we're starting to change into a gas a little bit. But you have more space between the particles, and that's going to cause them to take up more space. So for most materials, yes, there are exceptions, but for most materials, as you heat them, the particles will move apart because they're moving more, and they will expand. Okay, there's one last thing I want to take a look at. We're going to go back to our very first sim here. And that is, when is energy being transferred and how does that happen? If you watch one of these particles, so pick out a nice slow one, you'll notice it stays slow until a faster particle collides with it. And so this idea that we're transferring energy through collisions is going to be really crucial as we talk about what's happening as we heat and cool particles. But it's those collisions that are going to allow for a transfer of energy. Okay, so real quick, just to recap, particles are in constant random motion. Diffusion happens when particles move from an area of high concentration to low. That's going to be faster in a gas, both because in general those particles are moving faster and because there's fewer collisions, fewer other particles getting in the way of the spreading of our particle of interest. In solids, liquids, and gases, solids have the least motion and the particles are closest together, where gases, those particles are moving the most and the particles are farthest apart. As you heat something, those particles are going to move faster, and so in general they're going to expand. You especially see this with solids and liquids. Gases already take up lots of space. And then the last thing is that energy is transferred during those collisions between particles. Okay, if you have questions, make sure you write them down and bring them to class. We'll talk about it. Thank you.